All right, in this video, we're going to be talking about simplifying square roots with imaginary numbers. In our last square root video, we did real numbers. In this one, we're going to look at imaginary numbers. Now, we talked about imaginary numbers in Algebra 2, but you may not remember. We have this number I, and I is the square root of -1. By definition, that's what it is defined to be. So if I have, say, the square root of -56, I can rewrite this as the square root of 1 times the square root of 56. I know the square root of 1 by definition is I, and then I'm going to have to do a factor tree on the 56 to figure out what the rest of the answer is. But anytime I have a negative on the inside of my square root, I'm going to end up with an I. All right, similarly to that, we did a lot with I squared last year when we were simplifying things. Well, if I is the square root of -1, then I squared is the square root of -1 squared. You remember from what we talked about in our other video, squared and square root are opposites. They cancel one another out. So what we have left is -1. So I squared is equal to -1. And you'll need that when we do some simplification later. All right, let's look at what that's going to look like in our problems. So square root of 4, that's like what we did in the last video. Square root of 4 is equal to 2. But in this one, I have a negative inside the square root. So I know that's the same thing as the square root of -1 times the square root of 4. Square root of -1, I remember, is I, that's its definition. And the square root of 4 we just said was 2. So the answer to this one is going to be 2I. That I comes right after the number when you write it. And anytime I have a square root on the, a negative on the inside of my square root, I'm going to have I in the final answer. Okay, so look at this one down here. The negative now is on the outside. Well, that doesn't have anything to do with I. That negative on the outside just tells me that my final answer should be negative. I know the square root of 4 is 2. So the negative square root of 4 is -2. That negative that's on the outside just comes over as part of the final answer. Now this one has a negative on the outside and the inside. So this negative on the outside, we just looked at that, that comes down as a negative in the final answer. And that negative that's on the inside, well, just right above here, we realize that that is an I. So the answer to this one is -2I. The negative on the outside coming from here on the outside, the negative on the inside becoming an I. All right, let's look at that with some larger examples. So look at this one. The negative is on the inside. What does that mean for our final answer? Well, what that means is when we split this up, we're going to have square root of -1 times the square root of 128, and this one is going to have an I in the final answer. 128 is not prime, so I need to do a factor tree. I realize this is even, so I'm going to start off with 2. Sometimes people don't like to use 2. Like they feel like if they use 2, they must not be very smart, or they could have found a bigger number. But you know what? 2 is a prime number, and that's what I'm trying to get to. And 2 is also easy, so 2 is a good place to start. All right, 64 is even again. I'm going to keep dividing. 32 is even. Keep dividing. 16 is even. I'll keep dividing. 8 is even. And also 4 is even. So it's a long factor tree, but it wasn't very hard to do because 2 is an easy thing to divide by. Okay, so now I need to circle. How many numbers should I put in my circle? Right, you remember from last time, I should always circle pairs because square root is like unsquaring. And if you square something, you multiply by itself, which is 2 numbers. So I should circle groups of 2. Okay, so now we're ready to write our final answer. I have 1, 2, 3 groups of 2 to go outside. I'll multiply those together. 2 times 2 times 2 is 8. My I comes down right behind my number. And then my square root behind that, well, let's see what's left over to go inside the house. Only this 2 right here doesn't have a buddy. So he goes back inside. So the final answer is 8I square root of 2. This negative on the inside gives me an imaginary answer. All right, let's do this one. All right, this time the negative is here on the outside. What does that mean for the final answer? Well, it just means the final answer is going to be negative. This one does not have an I because 54 is positive. So I'm going to start off with a factor tree on 54. Okay, so I remember from my divisibility rules, 5 plus 4 is 9. 3 goes into 9, so 3 goes into 54. That only works for 3 and 9. Don't try it for other numbers. But for 3 and 9, that works. So I'm going to do 3. 3 goes into 5 one time with 2 left over. 3 goes into 24 8 times. So 3 times 18. Now you might have chose to start off with 9 times 6 because you remember that from your times tables. That's okay. We're both going to get the same answer in the end. 18 is 9 times 2. 2 is prime, but 9 is not, so I got to keep going. 3 and 3. Okay, so now let's circle our pairs. Well, I've only got one pair here. So on the outside, I'm going to bring over this negative for my final answer. My 3 that's circled. Now I'm going to leave a space right here for my variables because I don't yet know what's going to go there. Put my square root symbol over here. And this time I see that I have a 3 with nobody and a 2 with nobody. So I'm going to multiply those back together. 3 times 2 is 6. And that's what goes inside because neither one of them was a pair. They were both singles. Okay, now let's look at our variables here. Look at the exponents. What is it that we divide the exponent by? Right, we divide by 2. Because it's a square, right? Square is a number times itself, which is 2. 2 goes into 3 one time. 1 times 2 is 2, with 1 left over. Okay, so now remember from before, this number tells us the exponent that goes on the outside, and this number tells us the exponent that goes on the inside. So when I get ready to write my final answer, for the variable d, I'm going to have an exponent of 1 on the outside. You can choose to write that 1 or not choose to write that 1. It's understood. And an exponent of 1. Oops, that looks terrible. And an exponent of 1 on the inside. Okay, so now let's look at e right there. Well, oh dear, I don't see an exponent. Aha, I remember that means there's that understood 1 right there. So 2 goes into 1 0 times with 1 left over. All right, so that tells me I'm going to have an exponent of 0 on the outside, which means basically I'm not going to have an e on the outside. And I'm going to have an exponent of 1 on the inside. So let's write that e on the inside. I'm going to extend out my absolute value bar so d and e both fit inside of there. Okay, now also remember we talked about in the last video that we have to force this to have the same sign as this. Well, if this is negative, I've got my negative right there. This part is negative. Well, if d works out to be negative, negative times negative would be a positive, which is not what I'm saying that we have. We have to make it be a negative, which means d had better be a positive, because negative times positive is negative. So do you remember from the last video, what do we put on d to force it to have the sign that we want? Right, we put absolute value bars. Because that d has an odd exponent, it needs the absolute value bars. And again, like I said in the last time, I'm not sure if Delta Math requires the absolute value bars or not. But in general, if you were handwriting this, you would want to put those absolute value bars anytime you have an odd exponent. All right, so there's our final answer. -3 absolute value of d times the square root of 6de. All right, let's do another one. Ooh, look at this one. This one has a number on the outside. Let's see how that's going to affect things in the end. All right, first let's focus on this negative. What does that negative mean for my final answer? Right, this is going to be -1 times the square root of 180. So my final answer will have an I. This is imaginary. All right, let's do a factor tree on the 180. The 4 is not inside the square root. I don't need to worry about the 4. I just need to focus on the 180. So it has a 0, 18 times 10. Now last time when I did 18, I did 9 times 2. This time, just to show you it doesn't matter, I'm going to do 6 times 3. I know 3 times 2 is equal to 6. So look, for 18, I've got 2 3's and I've got a 2. If you look back at what we did on 18 last time, I had 2 3's and I had a 2. So it doesn't matter whether you start with 9 and 2 or whether you start with 6 and 3, you end up with the same thing. All right, 10 is not prime either. Let's do 2 and 5. Okay, let's do some circles. 2 numbers in my circle, so I've got 2's right here, got 3's right here, and I've got that 5 left over by himself. Okay, so now I need to take care of that 4. Well, that 4 is on the outside, and if you remember from when you first started learning algebra and pre-algebra, 8th grade, 9th grade, you learned that when there's nothing written in between there, it means multiply. So I don't see anything in between there. This really means 4 times the square root of this. So when I simplify this, basically I just need to multiply by 4. So I'm going to go ahead and put my 4 times right there. And now let's see what would happen. 3 times 2, those both are circled. 3 times 2 is 6. I'm going to bring over my I, because my I goes on the outside. Leave a space for my variables. 5 on the inside. Okay, let's look at those variables. Do you remember what you divide by? You divide by 2 on the exponents. 4 divided by 2 is 2, with none left over. No x in there. 5 divided by 2 is also 2, but I have 1 left over to go on the inside. So 4 divided by 2 is 2. 5 divided by 2 is 2, with 1 left over. I got my little understood 1 right there. Okay, now look at my exponents. Are either one of those odd? Nope, they're both even, so they're both fine. I don't need any absolute value bars, but I do need to simplify right here. I do need to multiply 4 times 6. 4 times 6 is 24. I got my I still on there. X squared, y squared, square root of 5y is the final answer. Okay, one more. Let's do this one. So this one has a number on the outside, but this time the number on the outside is negative, and I notice the number on the inside is negative. So what is that going to mean for my final answer? Well, it means my final answer is going to be negative, but also it means my final answer is going to have an I in it, because the square root of -1 is I. All right, let's do a factor tree. 5 goes into 13 2 times, 3 left over. 5 goes into 35 7 times. I picked 5 because my number ended in a 5, so I know it's divisible by 5. 27, I remember from my times tables, is 9 times 3. 9 is not a prime number, so I'll divide again. 9 is 3 times 3. Okay, so now I am going to circle what I have pairs of. In this case, I have a pair of 3's, only one 3, only one 5. All right, so let's see what goes on the outside. Well, I've got this -5 out here, and I know I need to multiply because there's nothing written right there. So -5 times. All right, now I'm going to have a 3 right there because I have 3 in my circles. And on the inside, I have a 3 and a 5. Multiply those back together. 3 times 5 is 15. Oh, and I left out my I. Let's put my I in there. Right from right here, I know that I should have an I in my final answer. So my final answer is negative from this negative out here, and also has an I from this negative right here. All right, let's look at my variables. All right, what is the exponent on that t that's right there? Right, it's that understood exponent of 1. So dividing by 2, 2 goes into 1 0 times, which means no t right here. I have a t right there. 2 goes into 2 one time with none left over, so I have no u right there. Let's multiply to simplify our final answer. -5 times 3, -15 iu, square root of 15t, and I notice that u has an exponent of 1, which is odd, so I put absolute value bars on it, and that is my final answer.